So in this video I'm looking at factoring quadratics, and I know these are quadratics because I have x squared terms in front, and I also generally have 3 terms as well, but not always. You'll notice these bottom 2 examples just have the 2 terms. But when we're factoring quadratics, we usually think about putting them into double brackets, and one of the first things we need to ask ourselves is how can we get 2 numbers that will times to the last number, and out of those a pair that we can get to add to the middle number. So if I think about things that will times to 39, I have 1 and 39, and I have 3 and 13. And 1 and 39 I cannot add together or subtract to get the 16, but 3 and 13 in fact do add together to give me 16. So I will write in my double brackets, I'll have an x and an x in the front, a 3 and a 13. Now I'm just going to pause and think about those signs. I need 2 numbers that times to a positive 39 and add to a positive 16. Because both of those are positive, I'm going to know that these both have to be positive inside the brackets. And that's part of what this little table up here hints at for us. If the middle term and the end term are both positive, then we need positives inside of both of the brackets. And the reason for this is because positive 3 times positive 13 will give us the 39. And 3 plus 13 will give us the 16. So that's our final answer. Looking at the next example, it gets slightly tricky, because we notice here that we've got a number in front of that x squared, or in this case an m squared. That number in front can make things more complicated, but if we think about it, I can actually factor a 2 out of all 3 of these terms. 2 times 1, 2 times 7, and 2 times 6. 2 times 7 would give me the 14, and 2 times 6 would give me the 12. So if I pull a 2 out of all of those numbers and put it in the front, I have just the m squared minus 7m plus 6. And now I just have a regular looking quadratic to deal with inside there, because there's now that invisible 1 in front of the m squared. So I'll leave the 2 in front, put in my double brackets, and now I need to think about what will times to positive 6. I've got 1 and 6, and 2 and 3. And out of these, which combination can I get a negative 7 with? So, trick here, I'm noticing the middle term is a negative, but the last term is a positive. And in this case, it's one of these situations where I've got a negative for the middle term and a positive for the end term. And how I can get that to work out is actually if I have a negative and a negative. Because a negative times a negative will give me the positive for the plus 6, but a negative plus a negative will give me the negative for the minus 7. So I go ahead and write in my m's, and I think, well, 2 and 3, they can't add together to 7, but 1 and 6 can, so I know it's going to be 1 and 6. And double checking, negative 1 times negative 6 gives me positive 6, and negative 1 plus negative 6 will give me the negative 7. And we leave the 2 in front, and you're done. This is a special case, this one here. These are perfect squares. And the hint for this one for me is 2 things. One, there's only 2 terms, an x squared and a 25. But the second thing for me is I'm noticing that 25 is actually a squared number. So if you can keep in the back of your head the squared numbers like 4, 16, 25, 36, 49, etc. When you see one of those in the situations, you should be thinking, ooh, perfect square. So how do I write 25 as a squared number? That is in fact 5 squared, so I can rewrite this now as x squared minus 5 squared. Sorry, these are not perfect squares. This is the difference of 2 squares. My mistake. Difference of 2 squares. Clearly a difference because we're subtracting the 2. So yes, it is an x squared minus a 5 squared, so it's the difference of 2 squares. Looking for that. And there's a special trick to factoring these because it's technically still a quadratic. So we'll put in the 2 brackets, and it's going to be x plus 5, x minus 5. Same thing happens every time. One will be positive, one will be negative, and you use the number that's been squared to give you the end term. And if you want to think about it from the way that we've solved these earlier problems, what times is to the last number and adds to the middle, Well, what times is to negative 25 but adds to 0 because there's no middle term? And that's kind of how you can think about this as well. So 5 and 5, positive 5 and negative 5 will times to get me negative 25, but a plus 5 minus 5, that actually adds together to give me 0, and that's why the middle term is not there. So our final answer here is x bracket x plus 5 bracket x minus 5. Another quick example of one like that could be a problem such as this: x squared minus 144. So 144 is actually 12 squared, so I can drop this into brackets. It's going to be x, x, 12, and 12. One will be positive, one will be negative. It doesn't matter which one you make positive or negative as long as one of them is each sign. So here, negative 12 times positive 12 will give us the negative 144, and negative 12 plus 12 adds to 0, which is why we have no middle term. Okay, looking at one more example here. This one is also slightly different because it just has the two terms. But you'll notice in this problem, the difference of two squares of the two terms, we had an x squared and then we had just a number. There's no x in it. But here I've got an x squared and a number with a single x. So in this situation, I can't actually put it into double brackets because I've got no in term to look with and to work with. So I'm going to ask myself another question. Is there something that both of these terms share in common? So if I think about the numbers, I could have 2 times 2 to make 4, and I could have 2 times 5 to make 10, so they both have a 2. I can pull out a 2. And this guy's got an x squared, and this one has an x, so I can actually pull out an x as well. And now to think about that again, I've got 2x times what will get me 4x squared? Well, I need to have a 2 in there and another x. So 2 times 2 is 4, x times x is x squared. I'm back to what I started with. I keep the minus sign there. I've pulled out a 2, I've pulled out an x. So 2x times what will get me negative 10x again? In this case, it's just the 5. 2x times negative 5 will get me negative 10x. And I'm back to where I began, so looking at how those two connect. So not double brackets here, but just pulling out the common factor. So those are a few examples of common quadratics that you'll see. Give a go doing some practice.